Good morning, students. Today we are starting with application of derivatives AOD, maxima and minima. What is maxima? Y is equal to fx is a given function. Then maxima is a point on the function y is equal to fx such that at x is equal to a, the value of fx is less than or equal to fa for all values of x. Now minima. Minima is a point x is equal to b on the function y is equal to fx such that at any point of the function the value of x is equal to b is less than the value of fx. Now we find out maxima and minima by two methods, first derivative test and second derivative test. The first derivative test is as follows. Y is equal to fx is the function given to us. First we find out dy by dx is equal to fx, that is equal to f dash x. We put f dash x equal to 0 and get the value of x is equal to a, b, c and so on. Take the value of x less than small a, then the value of x and more than small a. For example, if a is 2, we can take first x is equal to 1, then x is equal to 5. One value less than a and one value more than a. If the sign of f dash x changes from positive to negative at the point x is equal to a, then we have a maxima at x is equal to a. If the point at x is equal to a, the change in f dash x value is from positive to negative, it is a maxima. In case f dash x is equal to b, we consider the second point x is equal to b. If by taking a value less than b and then taking a value more than b, we get a change in sign of f dash x from negative to positive, then we get the point b as the point of minima. Minima is the lowest point. In case of f dash c, if there is no change in sign, we call it point of inflection, that is point of neither maxima nor minima. Now let us do these questions on the basis of first derivative test. First question is fx is equal to 1 upon x square plus 2, where x belongs to real numbers. Now f dash x is equal to minus 2x upon x square plus 2 as we get using quotient rule. Then put f dash x equal to 0. We get x is equal to 0. Less than 0, we have our point x is equal to minus 1. Let us put x is equal to minus 1 in f dash x. We get minus 2 minus 1 upon minus 1 square, that is we get plus 2 upon 3, which is positive value. Then we put a point more than 0, that is 1. We get minus 2 into 1 upon 1 square plus 2, that is minus 2 upon 3, which is negative. So you can see the sign changes from positive to negative as we put the values x is equal to minus 1 and x is equal to plus 1. So there is a point of maxima at x is equal to 0. Consider another question, fx is equal to x square, where x belongs to real number. Now f dash x is 2x. Put f dash x equal to 0. We get x is equal to 0. Below 0 we get a point x is equal to minus 2. Let us put x is equal to minus 2 in the function f dash x is equal to 2x. We get 2 into minus 2 minus 4 negative value. Now we take another value more than 0, that is plus 3. Put x is equal to plus 3 in f dash x, we get plus 6, that is positive. The sign of f dash x at x is equal to 0 changes from negative to positive as we move from minus 2 to plus 3. So we get at x is equal to 0 there is a point of minima. Now we consider the second derivative test. In second derivative test we have the function y is equal to fx. First we find out dy by dx is equal to f dash x. We put f dash x equal to 0 and obtain x is equal to a, b and c. We find the double derivative d2y by dx square, that is f double dash x. At f double dash x we put the value x is equal to a. If the sign comes negative, we have maxima at x is equal to a. If the sign is positive, f double dash x is equal to b, we get minima at x is equal to b. Now let us consider one of the questions. Fx is equal to x cube plus 3x square minus 105x plus 25. Find the point of maxima and minima. Let us find out f dash x. F dash x is equal to 3x square plus 6x minus 105. Let us factorize. We get 3x plus 7 and x minus 5. Now put f dash x equal to 0. We get x is 5 and minus 7. Differentiate f dash x again. We get f double dash x is equal to 6x plus 6. Put the value x is equal to 5. We get 6 into 5, 30 plus 6, 36 positive. So point of minima is at x is equal to 5. F double dash x is equal to minus 7 is 6 into minus 7 plus 6. That is minus 42 plus 6 minus 36 negative. That is the point of maxima at x is equal to minus 7. Now the second question is fx is given sin x in the interval 0 to 2 pi. Let us first of all differentiate fx is equal to sin x. You can see the graph also. At 0 sin 0 is 0, at pi by 2 sin pi by 2 is 1, at pi sin pi is 0, at 3 pi by 2 the value of sin is minus 1, and at 2 pi the value of sin is 0. Now f dash x is equal to derivative of sin x cos x. Put f dash x equal to 0. For what values of x between 0 to 2 pi cos x becomes 0 is cos pi by 2 and cos 3 pi by 2. That is x is equal to pi by 2 and x is equal to 3 pi by 2. Let us find out f double dash x. F double dash x is minus sin x. At f double dash x, first we equate x is equal to pi by 2 and we find the answer is negative. That is, there is a maxima at x is equal to pi by 2, as you can see, denoted by the point capital A. F double dash x is equal to 3 pi by 2. The value of f double dash x is minus minus plus, that is positive. So we get minima at x is equal to 3 pi by 2 denoted by point B. So this is how we find out derivatives. Second derivative method the value of maxima and minima. Now we will do few story type questions, and students, as many story type questions you get, please do it. Of all the rectangles inscribed in a given circle, fixed circle, square has maximum area. As you can see it in the figure, ABCD is a square inscribed in a circle with center O and radius R. The length of the rectangle is L and breadth of rectangle BC is B. And we can see that AC is 2R and AB is 2R cos theta. If we consider AC as 2R, AC is a straight line and AC is 2R. It is the diameter of the circle. So AB is 2R cos theta and BC is 2R sin theta. Area of triangle, area of square rectangle ABCD is AB into BC, that is 2R cos theta, 2R sin theta. We can write it as area equals to 2R square sin 2 theta, where it is given note sin 2 theta is 2 sin theta cos theta. So dA upon d theta, after differentiating we get 2R square 2 into cos 2 theta. We put dA upon d theta equal to 0 and get cos 2 theta equal to 0. If 2 theta is 0, so if cos 2 theta is 0, then 2 theta should be equal to pi by 2 and theta is equal to pi by 4. Let us find the double derivative. Double derivative is minus 2r square into 2 into 2 into sin 2 theta, that is minus 8r square sin 2 theta. Let us put theta is equal to pi by 4 in the double derivative. We get minus 8r square sin 2 pi by 4, that is minus 8r square sin pi by 2 minus 8r square, which is negative. Maxima at x is equal to pi by 4. So AB is equal to 2r cos theta and BC is equal to 2r sin theta. We get AB is equal to 2r cos pi by 4, BC is equal to 2r sin pi by 4. AB is 2r upon root 2, BC is 2r upon root 2. AB is equal to BC, length is equal to breadth, ABCD is a square. Consider this figure in question number 4. Show that semi-vertical angle alpha of the cone of maximum volume of given slant height, you can see slant height ABL, is tan inverse under root 2. How do we do this question? Given a cone of height h, radius r and alpha semi-vertical angle. Now we know sin alpha is OB upon AB, R upon L, where L is slant height and it is given to us and it is fixed. R is equal to L sin alpha. Cos alpha is OA upon AB, H upon L, then L cos alpha is equal to H. Volume of a cone we know is 1 upon 3 pi r square h, where r is L sin alpha and h is L cos alpha. L is fixed and alpha is variable. Volume is 1 upon 3 pi L square sin square alpha, L cos alpha, equating the value of r and h. V is equal to 1 upon 3 pi L cubed sin square alpha cos alpha. Now we differentiate V with respect to alpha. 1 upon 3 pi L cubed sin square alpha has derivative 2 sin alpha cos alpha. It becomes 2 sin alpha cos square alpha. Cos alpha has derivative minus sin alpha. Then we get minus sin alpha into sin square alpha sin cube alpha. Put dV upon d alpha equal to 0. So we get sin alpha 2 cos square alpha minus sin square alpha equal to 0. This gives sin alpha equal to 0, that is alpha is equal to 0. If alpha is 0, then it cannot be maximum, so this possibility we can rule out. We will consider the possibility 2 cos square alpha minus sin square alpha equal to 0. This gives tan square alpha is equal to 2, tan alpha is equal to under root 2 and alpha is equal to tan inverse under root 2. On the basis of perpendicular base hypotenuse, perpendicular is under root 2, base is 1, hypotenuse is under root 3, we can find out cos alpha is 1 by root 3, sin alpha is root 2 by root 3. So dv upon d alpha 1 upon 3 pi L cubed 2 sin alpha cos square alpha minus sin cube alpha is differentiated again to find out maxima and minima. d2v upon d alpha square is 1 upon 3 pi L cubed. Sin alpha has derivative cos alpha, so we get 2 cos cube alpha. Cos square alpha has derivative minus 2 sin alpha cos alpha, we get minus 4 sin square alpha cos alpha. Sin cube alpha has derivative 3 sin square alpha cos alpha with minus sign already there. So we solve it and we get 1 upon 3 pi L cubed 2 cos cube alpha minus 7 sin square alpha cos alpha, where sin alpha is under root 2 upon under root 3 and cos alpha is 1 upon under root 3. We find out the value of d2v upon d alpha square by equating the value of sin alpha and cos alpha as shown above. 1 upon 3 pi L cubed 2 1 upon under root 3 whole cubed minus 7 under root 2 upon 3 whole square into 1 upon under root 3. d2v by d alpha square is 1 upon 3 pi L cubed 2 upon 3 root 3 minus 7 into 2 upon 3 into 1 by root 3. We get d2v upon d alpha square as 1 upon 3 pi L cubed 2 minus 14 upon 3 root 3, that is 1 upon 3 pi L cubed into minus 12 upon 3 root 3, that is minus 4 pi L cubed upon 3 root 3. This is a negative value. The negative value tells us that the point is a point of maxima. We have maxima at alpha is equal to tan inverse under root 2. So the semi-vertical angle of the cone of given slant height and maximum volume is tan inverse under root 2. Thank you very much. Please do the exercise 6.5.